Okay, welcome back everybody. I received a really good question from one of your classmates, and he was asking for the difference between standard deviation and variance. Standard deviation and variance. So what is the difference between standard deviation and variance? In theory, variance is the same as the standard deviation. So variance calculates how far are the data points away from the mean. In fact, we use the exact same description for standard deviation. So the question becomes, what is the use of standard deviation if we know the variance? Or what is the use of variance if we know what the standard deviation is? So the difference is, when we calculate the variance of a given data set, the units of the variance will not be as same as the means unit. Let's go over an example. Let's say that we have 3 tables and we measure the length of those tables, and the length of those tables are 50 centimeters for the first table, 40 centimeters for the second one, and let's make it 60 centimeters for table number 3. So we want to see how dispersed these values are. Okay, so as we can remember, the first step is to calculate the average, right? The average is 50 plus 40 plus 60 over 3, and the average is 150 over 3, and it's 50. This was easy. And let's use the formula of variance, right? So as we can remember, the formula for variance was sigma square is equal to the sum of, this is I, this is N, sum of xi minus mu. Mu is the same as x bar, by the way, squared divided by n. Okay, so for each data point, we take that data point and subtract from our population mean, then divide by the total number of data points. This is what variance is. So let's plug in those numbers. The first thing that we need to find here is this, right? And this is the same as d squared, right? Because d is equal to xi minus x bar. Okay, so our x bar is 50 data points. The first table is 50 centimeters. The second one is 40 centimeters, and the last one is 60 centimeters. If you want to calculate d, this is going to be 50 centimeters minus 50 centimeters, and it will be equal to 0. And this is going to be 40 centimeters minus 50 centimeters. This is going to be equal to minus 10 centimeters. And the last one is 60 centimeters and 50 centimeters, and the answer is going to be positive 10 centimeters. Okay, so we know what d is. Let's calculate d square. So 0 square is equal to 0. Minus 10 square is equal to 100. 10 square will be equal to 102. So we take the sum of the square, and it will be equal to 100 plus 100 plus 0, 200. So it looks like we have all the data that we need to solve our equation. Sigma squared is equal to 200 because this value here is 200. 200 divided by n, and n is equal to 3. So sigma squared, by the way, this is in centimeters, right? So this will be in centimeters square, right? So let me just rewrite everything. So this is in centimeters square. Centimeters square divided by 3. And the answer is going to be, sigma square is going to be what? 66.6 centimeters square. Okay. So when we calculate the variance of this data set, the unit of the variance, which is here, this is our unit, right? It's centimeters square, is not as same as the means square, right? Our mean was what? 50, and this is 50 centimeters, by the way. So here the mean is 50 centimeters, and here our variance is in a different unit. It's centimeters square. But we would like to keep this in the same unit. So we take the square root of the variance, (66.6 centimeters square), right? And sigma will be equal to what? 8.16 centimeter. So the one that we find here, let me use a different color. This is standard deviation. And the one that we find here is the variance. And the variance is in a different unit than the means unit, because the means unit was centimeters and this is centimeters square. But the standard deviations unit is in centimeters. So it looks like we have a winner here, right? This is our winner because this unit, which is in centimeters, is as same as the means unit, which is in centimeters as well. So this is the exact reason why I need you to use standard deviation in our calculations, unless I ask for variance. If I ask for variance, go ahead and calculate this. But if I ask you to tell me how dispersed the data are from the mean, you need to calculate the standard deviation. Okay, I think it's clear, but let's just go over a few examples. Give me 1 second. Okay, I guess I'm ready. It's almost done. So we will be doing additional questions which will reinforce the learning process. So example number 1. The standard deviation is the square root of the variance. So if we calculate the variance as 16, the standard deviation is the square root of the variance. The square root of the variance. So square root of 16, which will be equal to 4. Example number 2. If the variance is let's use 25, the standard deviation will be equal to the square root of 25, which is equal to 5. Okay, example number 3. Let's say that we calculate the standard deviation, and standard deviation is equal to 3. So can we calculate the variance from the standard deviation? Yes. So the variance is the square of the standard deviation, which is 3 squared, and it will be equal to 9. Example number 4. If standard deviation is 10, the variance is going to be 10 squared, which is equal to 100. So we can keep giving more examples on this case, but the take of this video is that the standard deviation is the square root of the variance, and the reason that why we would like to use standard deviation is that because when we calculate the variance of any given data set, the unit of the variance is not going to be as same as the means unit, like the example that I just gave about 5 minutes ago. So if the means unit is in centimeters, the variance unit will be in centimeters square. Or if the means unit, if it is in kilograms, the variance unit will going to be kilogram square. So since those two units are different, we would like to take the square root of this variance. The square root of kilogram square will be equal to kilogram. So it will be as same as the means unit, right? So again, yes, variance and standard deviation are the same thing. In theory, variance is as same as the standard deviation. But standard deviation is more important because it will give us the same unit as means. So if I ask you a question, calculate the standard deviation, right? If I don't ask, if I specifically ask for variance, then I need you to calculate the variance. But the reason that I made this video, because again, I received a really good question from one of your classmates, and he said he did not understand the difference between standard deviation and the variance. And here's the difference, right? So in the past 14 minutes, we've been talking about the difference between standard deviation and the variance, and I hope everybody understood why we use standard deviation over variance. So this is it. Those are all the good questions. Please keep asking questions, and I'm gonna try my best to record a video to answer your questions. If not, I can just reply to your email and send your question to everybody and send my answer to everybody, so that students get the opportunity to see the different types of questions that come from the students. Again, if you have any questions, please let me know. I'm here to help. Thank you.